Okay, so today we're going to finish chapter 2, which is ratios and proportions, and then I'll give the due date for the assignment. At this point, I don't think we'll be having a test for chapter 2 because it's just not that long of a chapter. So yeah, it'd be kind of too similar to the assignment. So yeah, so there's just the assignment that you have to worry about. Let's see, what else is there? I guess that's everything in terms of reminders. Okay, so let's start. Okay, still recording, good. Okay, so this is 2.2, it is percentage problems. So this is solving a very particular type of proportion. So in this type of question, you'll be given 3 different quantities, and your goal is to solve for one of them. So you'll be provided with the value for 2 of them, and you got to solve for the remaining one. So we have 3 different quantities that we're dealing with. Maybe I should, okay, I'll just stay with the PowerPoint for now. Okay, so these are the 3 quantities. The first one is called B, and that is called the base, and that will be a larger number within the problem. So B is a larger number. P, on the other hand, is a smaller number. So P, it represents part, so smaller number. And we'll go through an example of this in a second. And then R is representing a percentage. So R stands for rate or percent. So that's a percent that's associated with these 2 previous numbers. So R is a percent. So those are the 3 quantities we'll be dealing with. So let's look at an example that kind of connects all of these together. So we're going to look at a statement, a fairly short statement. Okay, here is the statement. 75% of 4 is 3, which is a true statement because, 3 to 4 is 75%. So in this case, we have all 3 of these quantities. So 75% represents R. The smaller number in this case represents P, and then 4 in this case is represented by B. So we got our R and our B and our P. So basically what you have is a ratio between a smaller number and a larger number, and then R is the percent associated with them. Like if you had the ratio of 1 to 2, then in that case, R would be 50%. So it's basically just comparing the 2 numbers and giving you a percentage of how much the smaller number is compared to the larger number. And in this case, you could write this in multiple ways. Like, for example, you could write it as 3/4 equals 0.75. You could write 3/4 equals 75%. The way we write it is with a proportion so that we can actually manipulate it and solve for things. So here's the official way that we write it. 3/4 equals 75/100. So that's just another way of saying that 3 out of 4 is 75%, or 3 is 75% of 4. In this case, we don't need to write a percentage sign because you automatically write the 75 being over 100, and that makes it a percent by definition. And it also turns it into a proportion. So that's how we'll be dealing with this. And let's go to the previous one. So here is the actual official formula that we'll be using. So this is used for all of the percentage problems. So this is just the more generic version of the example that we just looked at. So here is what we have. Smaller number divided by larger number is equal to our percentage over 100. So typically what will happen is you'll be given a statement and it'll provide to you 2 of these variables, and then your job is to solve for the third one. So part of the problem is identifying what variables the question is giving to you. Is it giving you like P and B and asking for the percent, or is it giving you the percent and the larger number and asking you for the smaller number? There's a couple of different iterations that they can give you. So I think we should let's just look at an initial example to see how these work. Let's see, okay. I'm gonna do this on a whiteboard. So the first question is, what is 30% of 50? So let's write this down. What is 30% of 50? Okay, so in this case, for a lot of these, there's kind of easier ways to solve them. If I'm being honest, compared to proportions, like for example, in this case, you could just take, well, first of all, it's asking, what is 30% of 50? So the easiest way would be just to take 50 and multiply by 0.3, and that would give you the answer. But in a lot of cases, it's a little more difficult than that. So it kind of makes sense that they give us more of an formal algorithmic way of solving these, which is using proportions. So let's look at this one. So what numbers do they actually give us? Let's just write down B, P, and R, and let's just identify which ones we get. So the 30%, the percentage part will always be R, so that's the easiest part. Let's start there. So R equals 30. And it says, what is 30% of 50? So in this case, 50 is the larger number. And then after you take 30% of it, you would end up with a smaller number. So in this case, 50 is B, 50. And then our smaller number is unknown at this point. So that's what you do first. You write down your variables and you establish what they're actually giving you. And then next you write down just the generic version of this proportion. So P over B equals R over 100. And then the next step is you plug in your variables and you make sure you plug them in where they actually belong. Because one common mistake I notice with a lot of students is they'll just kind of plug things in randomly without really using any logic. Typically, they'll just plug stuff into the left side of the equation, even if that stuff doesn't really belong there. So you do have to make sure you plug stuff in exactly where they belong. So for example, 30 is R. So 30 will go over right here. And then B is 50. So 50 will go right there. So you just have to make sure that you plug them into their actual corresponding letters. Otherwise, of course, you'll get the wrong answer. Oh, hold on, sorry. I just have to read this. Oh, sorry, okay. Let's see. So let's plug these in. So this gives us P over 50 is equal to 30 over 100. So this is just expressing that, this smaller number compared to 50 is equal to 30%, or the ratio between them. And then the last step is just solve for your remaining variable. So solve for P, and you just use the previous methods that we learned. So in this case, you have divided by 50. So you just move this to the other side and change it to multiplication. And someone said 15. 15 sounds reasonable. Yes, it'll end up being 15. So the way we get that is take the 50, move it over, change it to the other side. So then you get 30 times 50 divided by 100. So the 50 just goes up and joins the 30 on the top, which is 1500 over 100, which is equal to 15. So in this case, you would conclude, therefore, P is equal to 15, or the smaller number equals 15. And yeah, so that's basically what you do for these. It's a very specific type of problem, so it's pretty limited. There's only really 3 different iterations of this problem. Of course, there's solving for B, solving for P, and solving for R. So yeah, there's not that much variety to these types of questions. And what else can I say about that? Okay, let's do another one. So the next one is, hold on, I'll just show you the next one, but I don't think we'll bother doing it because it's equivalent to this one. Yeah, the next one just says, what is 2% of 140? But I think we'll skip that one for now because that is, yeah, again, that's the same one. It gives you the same info. So let's do a different one. I'll leave that for practice. Okay, let's get rid of this. Okay, so what percent of 8 is 5? That is our next question. What percent of 8 is 5? Okay, so first step, write down all of your variables and decide which ones it gives you. So it does not give you a percent at this point. That's actually what you'll be solving for. So let's just put r equals question mark. And then the rest of it is pretty easy. Of course, 5 is going to be your smaller number and 8 is going to be your larger number. So b equals 8 and p equals 5. So, and then the answer, of course, will be, 5 compared to 8. How much of a percentage is that? You should expect the answer to be above 50% because like 4/8 would be 50%. So 5 compared to 8 should be a little more than that. So yeah, the answer in these cases, you can kind of anticipate a little bit. Okay, now let's set up our proportion. Oh, let's see what someone's saying. Oh yeah, someone already figured it out, but I don't want to give away the answer. Okay, so our proportion is P over B equals R over 100. Okay, now let's plug everything in. So in this case, everything happens to go on the left side because you have P and you have B. So let's plug those in. So P is 5 over 8 equals R over 100. And then the last step is always the same. Take your last number, move it over, and just remember the rule that you have to change it from the bottom to the top. So then R is going to be 100 times 5 over 8. So that's 500 divided by 8, which is 62.5. And yep. So within the problem, you don't actually need to put a percentage sign because you already are saying R is equal to 62.5. And within the problem, R is already initially over 100. So when you're stating R equals something, it's technically improper to put an actual percentage sign. So yeah, in this case, you could just say R equals whatever number. On the other hand, if you're just stating the answer in general, then you could say, therefore, the answer is 62.5%. So in this case, you should kind of choose one or the other, either just say that R equals whatever number it is, or just generally state it as a percent. But that's kind of just like a technicality. That's not a big deal. Another thing I would say is make sure that you write down this generic version of the proportion first before you plug anything in, because when people just plug it in, I don't think I've ever seen anyone get the right answer because they just always plug it in incorrectly, because there's a lot of different ways of doing these wrong. Like for example, let's see like a mistake that someone can make. So yeah, typically if someone just plugs it in without bothering to write out the actual portion, they just write weird stuff like they'll write R over 8 equals 100 over 5. And it's like, what's going on? Like the R isn't even with the 100, the 5 isn't with the 8, everything's on the wrong side. Yeah, so you can't just toss everything in and hope that it all comes together. So yeah, write this part down first and then just plug everything in appropriately. Okay, so that was the second type of problem. Let's see, and then again in the PowerPoint, you kind of have a replica of this problem where it's asking the same thing. It's asking what percent of 40 is 16? So again, I'll just leave that for everyone to use for practice. And now let's do the last one, which is definitely the most difficult one. I mean, it's the same amount of work, but the question itself can be hard to get correct. The wording is kind of weird. So here is the last one. It says 30% of what number? 30% of what number is 8.7? So you have to look at this very carefully because it's not actually asking what is 30% of 8.7. What it's actually asking is 30% of what number equals 8.7, which is technically different. It's saying 30% of what larger number would give you 8.7, a smaller number. So yeah, it's kind of asking it in a backwards way. But basically what you have to do is backtrack and figure out what would be the larger number such that 30% of it is 8.7. So you do have to read this one super carefully because it looks similar to the first type of question that we did, but it's actually asking like the opposite thing. So in this case, let's write down all of our variables. Start with the easy one, r equals 30. So in this case, the number we're looking for is the hypothetical larger number, and then 8.7 is hypothetically smaller. So in this case, 8.7 is actually p. And we're going to be solving for b. Okay, so same thing. Let's set up our proportion. P over b equals r over 100. And now let's plug everything in. So again, plug them in where they belong, because if you just plug stuff into the left side right here, that doesn't make sense because b is what you're trying to solve for. So it wouldn't make sense to plug something in for it. So yeah, again, I'm just trying to stress that that point. Okay, so now let's plug stuff in. P is 8.7 over b, which is just unknown at this point. And then r is 30. So 30 over 100. So this one is more difficult both in the wording of the question and then solving it is a tiny bit more difficult because the variable happens to be on the bottom. With the other questions, the variable will always happen to be on top. So let's solve this. I think the easiest way is let's just take each side and flip it upside down. And that'll bring the b on top. So b over 8.7 is equal to 100 over 30. And then last step is take the 8.7, move it over, and move it to the top. So then you get b is equal to 100 times 8.7 divided by 30. And that is equal to 29. So in this case, that makes sense. It's basically saying that like if you re-input this into the original statement, it's saying that 30% of 29 is 8.7. So yeah. So make sure you read these questions carefully. What else do we have? So that's, yeah, those are the only 3 iterations of these. So they're not too bad. Last question is 16% of what number is 5.76. But again, that's equivalent to this one. So I'll leave this for practice. And then if anyone wants any extra examples, then we can take them up on Monday or whatnot. Okay, so that was way shorter than I thought it would be. Let's see what else. So we are done. Yes, we've done that. We've done that. Yeah, so it looks like we are done the chapter. Okay, let's stop sharing. Okay, so now we have to figure out the due date for the assignment. So today is Friday. What will be a logical due date? Maybe we'll just make it due next Friday, and we'll also take it up next Friday as well. Because then you have plenty of time, and yeah. But in that case, just note that there's no late option because it's already been up for a week, and this is giving you another week. So yeah, we'll take it up on Friday. So it just has to be in by then at the very, very latest. And I'll put that all in writing on iLearn. And now let me just double check the attendance. We have that person. This person, this person. Okay, almost everyone is here. That's impressive for a Friday class. Let me just see this person. And almost done. Okay. Yep, so like I mentioned, no test for this unit. I'll also post the next unit, which is measurement. And then, yeah, so I guess that's it. Does anyone have any questions? Okay, cool. So everyone, thanks for coming, and have an awesome weekend. And thanks. Have a good day.
Thank you. You too.
Thank you.